Welcome back, my beautiful students. You look great today, by the way. But anyway, so we're going to be finding the area of each sector in this problem, which you're probably like, what's this sector business? Well, let's go back to the Prezi because I can explain what that is on the Prezi. All right, so the sector area, the formal way of stating this, it's the area of the region in a circle bounded by their two radii and their intercepted arc. So we got a radius and an arc. So this is the intercepted arc. So it's the shaded region bounded by those pieces. But the informal way to say this is it's basically just like a chunk of the area of the circle. It's like a piece of the area. So it's kind of like if you had a pie and you cut yourself, this would be a really large piece of pie or cake, which is pretty awesome because I love pie and cake. So I would be okay with this piece of pie or cake. But anyways, it's kind of like you just take a piece of the entire area. So it involves the area of a circle and the fraction of the circle that you're dealing with, which that will make more sense in the formula. Okay, so the formula starts with pi r squared, which we know is the area of a circle. Okay, then we're going to multiply the area of the circle by the fraction of the circle we're dealing with, which, how many total degrees are in a circle? There are 360 degrees. So if I knew the degree of this angle right here, or this arc, that would tell me how many degrees out of 360 I'm dealing with, which is the fraction of the circle. So it's like you multiply the area of the circle by the fraction of the circle you're dealing with. And that will give you the area of the sector, okay? Which x is going to be the measure of the sector's central angle in the degrees. So if you know, blah, 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 cannot talk. If you know the central angle, then you're golden. Okay, technically the central angle is equivalent to its intercepted arc. So if you know the intercepted arc or the central angle, then you'll have the value of x. So again, we're basically multiplying the area of a circle times the portion of the circle that you're dealing with. So we're really not introducing a complete brand new formula. It's just kind of an extension off of the area of a circle formula that we've been working with. So let's get going, you guys. Okay, so I'm going to write that area formula down so we're golden on that. So we know the area of a circle is pi r squared. And then we're going to be multiplying it by the fraction of the circle we're dealing with, which is the degree of either the intercepted arc or the central angle over 360, because there's 360 degrees in a circle. Okay, so let's get going, you guys. So area equals pi. Now, what is the radius of the circle in my picture? Well, the radius is this bad boy right here. So the radius is 3. So it's 3 squared times x is the degree of the central angle, which I don't have the degree of the central angle, but the central angle is equal to its intercepted arc, which the intercepted arc is arc MN. So if the intercepted arc is 80 degrees, that means that my central angle is also 80 degrees. Whoa. Okay, so it's going to be 80 degrees over 360, which that gives me the fraction of the circle, or the area of the circle that I'm dealing with. So this is the portion of the area that I'm looking at. So that's all we do. And we just simplify things down. So let's get going. Okay, so area equals pi times 3 squared, which 3 squared is 9. So I'm going to write 9 pi because, you know, the number comes before the pi, which doesn't make any sense, but that's just how it is. So 9 pi, and I need to reduce this fraction down. So I'm going to kind of reduce that bad boy down here where I have a little bit more space. So 80 over 360 down here. And that's a degree. 360 degrees, 80 degrees. Okay, which I know they both have a 0 in it. So if I divide by 10, it'll make the 0 go away. Okay, so it's really like I'm dealing with, I'm sorry, the 0 go away. I canceled out the degree. Silly Muslim. Okay, if you divide by 10, it makes 1 0 go away, which each of them had 1 0. Okay, so I'm looking at 8 over 36. So what is something that goes into 8 and 36? Well, I know that 4 does, so I'm going to divide 4 into each of those bad boys real quickly. So I'm going to divide each of these by 4. Okay, and that will give me 8 divided by 4 is 2. Over 36 divided by 4 is 9. So this is simply 2/9. So I'm dealing with 2/9 of the area of the circle. So I'm going to multiply 9 pi times 2/9. Which hopefully I won't run into this. I'm going to box this off just so things don't get complicated if I happen to move my way down there. So 9 pi times 2 over 9. Okay, which the degrees do technically cancel each other out, so I don't really have degrees anymore. So if that's helpful. Okay, so now I just need to multiply, which 9 pi is secretly over 1, and since I have fractions, it might help me to write over 1. Okay, so how do you multiply two fractions, you guys? You do go straight across. Nice. Okay, so our area is going to be 9 pi times 2, which is 18 pi, over 1 times 9, which is 9. And then I can reduce that down further. 18 over 9 is 2. So area equals 2 pi. And then my units are in inches. So I'm going to write inches squared. So area is 2 pi inches squared. And guess what, you guys? That's all we got to do. So our problem for that one is donezo. Cool, right? Example 5 is really similar to this one. So if you understood example 4, why don't you try example 5 on your own?